All right, so really quickly, I want to go through how do we actually find good embedding models. Uh, there has been, the open source community has already done a lot of work on judging or evaluating embedding models. The current benchmark leaderboard that is the most popular for text embedding models specifically is the MTEB. That is the Massive Text Embedding Benchmark. It's hosted on Hugging Face and it evaluates embedding models across 9 distinct categories. So these are the categories here. I'm not going to read through all of them, but I am going to make some, some clear points. Is that we do want our embedding models to be able to encode different languages, right? So there's several different languages in the world, thousands of different languages. And so embedding models, in order for them to be good in today's world, they need to be able to work with multiple languages. And so the first one is going to be the bit text mining. Bit text mining is we are trying to find the same sentence in 2 separate languages. The rest of them, we see that there's some classification and clustering, right? So embedding models are used for a lot of classification and clustering tasks. And, so we have different types of classification and clustering that we use to measure them. We have straight up classification and clustering, where classification is, its ability to be able to use this embedding model to assign a label to a piece of text. And clustering is, how well it actually groups similar documents together. But we also go a step further. We do multi-label classification, and where we're trying to assign multiple labels, to a multi-class classification problem. Now, I will say that, there are, so semantic textual similarity and pair classification seem pretty similar if you're reading this. Pair classification is, we're trying to give the model 2 pieces of text and be able to see if we can determine if they're similar or dissimilar. STS is the same, similar, it's the same sort of task, is that we're trying to determine how similar 2 texts are, but they use different formulas. So we won't go through the formulas, but their formulas for measuring the model's scores of similarity are different. And then, we also want to be able to use these models not for just classification tasks or clustering or have multilingual capabilities, but will be using this primarily for retrieval. And so embedding models are used for search applications, recommender systems, other types of applications where you really need to be able to retrieve relevant documents to either a query or another document or any sort of user input. And so instruction retrieval are used, our models are benchmarked against those 2 tasks. And then re-ranking. So re-ranking is a part of retrieval. Re-ranking is when you've already done retrieval, right? You've retrieved these relevant documents. Re-ranking is going to re-rank them based off of similarity to the query. And so that is how we evaluate the current models in the open source community. Let's pop over real quick to Hugging Face to see what this leaderboard actually looks like. Okay, so we're here on the MTEB embedding leaderboard. Here on the right, you can toggle between English and multilingual. We're going to stay on multilingual because embedding models, in modern day use cases need to be able to understand other languages, and they benefit a lot from understanding other languages. So, and it's a more extensive benchmark. So as you can see right here, we have this chart right here that displays the number of parameters of all of these models that's been evaluated and their average score across all the 9 benchmarks. And as you can see, there's a pretty strong correlation between the size of the model and its performance, its average performance across all the tasks. Here you have the top performing model is going to be Qwen 3's embedding model, all the way down to our all mini LM, which I cannot find, but it's somewhere around here. And so if we go scroll down, we have all of these models in their rank across the benchmark. We have their memory utilization score, the number of parameters they have, the embedding dimensions, the maximum number of tokens they can take in, so their context window. And then if you scroll to the right, you can see their scores across all these different benchmarks. And so you can go through here and evaluate these models based on your specific use case. If you're really concerned with retrieval and you don't really care too much about bit text or classification, then you can focus on the retrieval aspects of these, the retrieval scores of these models. And you can also download this table. So if you click download right here, it will download a CSV and you can do further analysis. And if you see a model that you like Qwen 3 here, we can click on Qwen 3 and we're going to be taken to Qwen 3's model card. And here is Qwen 3's model card for the 600 million parameter model, and all the information you need about it right here. And so I highly suggest starting here and finding a good model. Now, in terms of a domain-specific evaluation, whether this is financial, health, legal, or whichever domain you're in, and especially for your specific task within that domain, I would create your own evaluations for that model. So take this as sort of a general, take the MTEB as sort of a general evaluation. It's a good one, but just take it as sort of a general one. And then for your own domain and your own task, do your own personalized evaluation of the models as well. So that's how you take a more structured approach into selecting a text embedding a model. Now for this next lesson, what I want to do is take a step into multimodal models that can take as input images.